Looking at section 7.3, part 2, continuing with our partial fraction decomposition. And this time we are looking at what happens when we have repeated linear factors. It tells us that the form of the partial fraction decomposition for a rational expression containing the linear factor ax plus b occurring n times as its denominator is. So what happens when we have a factor that's going to occur more than one time? So we might have something that's a power of 2, a power of 3, a power of 4, etc. So it tells us that we are going to include one fraction with a constant numerator for each power of ax plus b. So we're going to start with that ax plus b to the first power, to the second power, to the third power, until we get to that nth power. So however many times we see that binomial, so to speak, or that linear factor, first power, second power, third power, until we get to whatever power, that's going to tell us how many fractions we're going to end up setting up. So let's take a look at an example. It says find the partial fraction decomposition of, we have an x plus 2 divided by that x times, we have an x minus 1 squared. So we need to take a look at our denominator and find all of our factors. Well, the first factor that I see is we have an x. We have an x minus 1 that would be to the first power, which we're just going to write as an x minus 1. And we also have that x minus 1 to the second power. So that means we are going to have three fractions set up. The first fraction is going to have x, because that was the first factor we saw. It's going to add with, the next fraction is going to have an x minus 1. And then we have a third fraction that's going to be that x minus 1 squared. And so we set up our numerators as our a plus our b plus our c. Then we go on to step number 2. It says multiply both sides of the resulting equation by the least common denominator. So I'm just going to rewrite this. We had a over x plus we had b over x minus 1 plus c over the x minus 1 squared. Those were our three possible denominators if we break that down. So they want us to go ahead and multiply by the least common denominator, and that least common denominator is just going to be what was in the original equation. So we're going to multiply both sides of our equal sign by an x with an x minus 1 squared and an x with an x minus 1 squared. And we're going to do just like what we did in the last section. These denominators over on that left-hand side are going to cancel out to just leave us with this x plus 2. This x would cancel out this x. So we would be left with that x minus 1 squared that's going to multiply by an a. So we're going to have a that multiplies by that x minus 1 squared. Then I go into my next piece. My next piece tells us that we have an x minus 1. The x minus 1 is going to cancel out one of those x minus 1s, which means we'd have an x left over and an x minus 1 that would then have to multiply with b. So we're going to have the plus b times, and you can use brackets, you could use double parentheses, whatever works best. We're going to have an x times that x minus 1. And then we have our last piece. Our last piece tells us that we have this x minus 1 squared. That's going to cancel out the x minus 1 squared to just leave us with an x that multiplies by c. So that means we're going to have a plus cx. And then we're going to have a little bit of simplifying to do. So you can simplify there, or on the next slide, it tells us to simplify the right side of that equation. So if we simplify this down, let's see what we have. We have an x plus 2 is equal to. Now, if I have an a that's multiplied with that x minus 1 squared, we're going to have an a that's going to multiply by x minus 1 squared, square double squared. We're going to have an x squared. We're going to have a minus 2x and a plus 1. Then we're going to have this b that's going to eventually have to multiply out with, let's simplify inside of this. That's going to give us an x squared minus x. And then we have that plus cx. And I'm not done simplifying because I still have some parentheses going on. So let's simplify some more. If I distribute out my a and distribute out my b, we have an x plus 2 is equal to an ax squared minus however order you want to write that in. It's kind of a 2ax plus 1 times a is a. Multiply out that b, we're going to have a bx squared and a minus a bx. And then we have that plus cx. And now we have to organize some things. Highest power that we have are x squareds. I have an ax squared plus a bx squared. So I have an ax squared plus a bx squared. Kind of putting those like terms together. Let's see what else we have. We have a minus 2ax, and we have a minus bx, and we have a plus c. So we have a minus 2ax, a minus a bx, and a plus a cx. And then we also have this last little guy over here. We have this plus a, and that's just a single a term. It has no x involved, so that's like our constant term. So if we were to kind of break this down, example or part 4 tells us to write both sides in descending powers and equate coefficients of like powers of x, and then equate the constant terms. Equate just means set them equal to each other. So if we were to break this down even a little bit more, so I'm just going to fill back in up on the top part that x plus 2 was equal to. Now, when I go about looking at these individual pieces, I have, excuse me, an x plus 2 is equal to, in common between those two pieces are an x squared. So I could use my distributive property to say a plus b would multiply with an x squared. My next piece here has all those x's involved. So if I were to take a look, let's see, we have a negative 2a, we have a minus 1b, and we have a positive c, and that is all going to have an x involved with it. So I'm just going to put a plus sign here, and I have a negative 2a, a minus b, and a plus c, and that's all my x terms. And then the very last piece that we have is that plus a. So all I did is I factored out what was in common, kind of that reverse distributive property. And now I need to make some pieces in terms of what do I have. Now, I have some x squareds. Do I have any x squareds over on my left-hand side? That's technically a 0x squared, which means a plus b is going to equal 0. My next piece that I have is I have my x's. If I have a plain x, this piece here is going to equal my x's. Well, if I look over here, all I have is a 1x. That tells us a negative 2a minus b plus c is going to equal a positive 1. I don't like that one. And then the very last piece that I have is I have this plus a, which means that I'm going to have just a plain constant term. A is going to equal 2. Step 5, we need to solve that resulting system for A and for B. Oh, I guess in this case we also have a C. So solve for A, B, and C because we have 3 terms here. Let's write out our system. We said that A plus B is equal to 0. A negative 2a minus a b plus a c was equal to 1. And then A was equal to 2. So we need to solve for A, for B, and for C. Well, guess what? We already got one of them. A is equal to negative 2. Perfect. Let's see where we can plug that in and solve down. If I go to this top equation, if A is equal to 2, 2 plus B is equal to 0, which means that B is equal to negative 2. Got another one. So now that I have A and I have B, let's take that last one here and let's find C. So negative 2 times an A value of 2 minus a B value of negative 2 plus a C value is equal to 1, which means negative 4 plus 2 plus C is equal to 1, which means negative 2 plus C is equal to 1, which means C is equal to, add the 2 on over, we get C is equal to 3. Now I have my A, my B, and my C. I can set up that very last piece. So once I have A is equal to 2, whoops, wrong one. A is equal to 2, B is equal to negative 2, and C is equal to 3. We can set up those partial fractions. So x plus 2 divided by x times x minus 1 squared is equal to 2 divided by x. I have a negative 2 for my b, so I'm going to write this as a minus instead of calling it plus a negative. So minus 2 over the x minus 1, and then plus 3 over that x minus 1 squared.